Hi, in this session I am going to talk about form control measures. The form can be controlled either using mechanical form breakers or we can use chemical antiform agents. Mechanical form breakers are special setup of fermenter or an equipment. Antiform agents are chemicals which can be incorporated into the medium. So mechanical form breakers, in this figure you can see figure of the form breaker. So this is a typical diagram of a fermenter. We have the fermenter here and this is a motor for agitation to mix the fermenter. So here we have three different layers of agitators. All three of them is used for mixing the medium. But on top of that they have an additional impeller. This is what we call the impellers. So which act as a form breaker. So the amount of media, the level of media will be somewhere here. Here we have the media level. So the level of foam breaker, there is no medium. Once the media has the forming capacity or the to produce a foam, the foam will increase the level into the level of this foam breaker. So once it reaches the foam breaker, it is continuously rotating. It will accelerate the foam into the walls of the fermenter, so which leads to the breaking down of the foam, and it will be foam won't go beyond the foam breaker point. That's one way of design. It can be used as a mechanical foam breaker for some fermentation. Another strategy for mechanical foam breaking is, here is a fermenter where actually the foam is pumped into another foam collector. This is foam collector. Once the foam is produced, we will have a piping. So this piping is used to collect the foam into the another container. So it's called foam collector. In this container, what we do, we will actually break the foam using some mechanical setup, and one after breaking the foam, we will transport the foam back into the media, the media once we break the foam, we will get the liquid. This liquid will be transported, or we will put the liquid back in the media. So that's another setup. So here we have a separate foam collector, and what happens in this foam collector is represented here. We can break foam in a foam collector in different ways. Here if you look at the image, the foam is transported in this tube. It is coming out here, but here is a motor and a rotating thing. This rotating shaft will break the foam, and it will be converted into condensed form. Condensed form will be collected and it will put back in the medium. In this thing we are using vacuum for that. The foam is pumped into a container, is this space. Here we are applying vacuum. The vacuum leads to the breaking down of the foam, and we will get the condensed form in liquid form. It will be uh, again, it will go to the media, the fermenter. In this setup we have something like a uh, centrifuge. The foam is placed in a rotating basket, spinning basket. Once it is in the basket, it is rotating very fastly. It will be accelerated against the walls of this basket, which is then breaking of the foam happens because of the rotation. So the we will get the condensed foam. We will put this back in the fermenter. Here we have a motor. The foam is coming through this tube, big tube. At the end of the tube, we have a motor and a shaft. It will break the foam. So we can, in the foam collector, we can use either any of this setup to break the foam, get the media back, and this media will be placed again into the fermenter. So mechanical foam breakers are good. We are not adding any chemicals. We are just mechanically removing the foam, but it's always a additional step. We need energy for doing all this, so we need electricity, we need additional equipment, and we have an additional step to break the foam. But in most of the cases, what we do, we use chemical antifoam agents. Chemical antifoam agents are chemicals. If we are incorporating this chemical into the medium, or we are adding into the medium, it will reduce foaming. So they are chemicals which reduce formation of foam during fermentation. These are basically surface acting agents. As we say, the forming is forming is due to the proteins, denaturation of proteins. Once the proteins denatured, it form a thin film above the medium, which trap air bubbles and cause foaming, and it leads to the secondary foaming also. So what we do, the chemical antifoam agents are surface acting agents. It remains in the surface of the media. What it do, it will reduce foaming by reducing the surface tension of the film. So in order for foaming, there should be a formation of the film, a continuous film which can trap the air bubbles. So once we have the antifoam agents which float in the media, and it will be in the surface of the media, which will destabilize the film so that there won't be foaming. So surface setting agents, it reduces surface tension, it destabilizes the floating film which is essential for the foaming, and another characteristic is spread it rapidly on the surface of the film. So as it actually destabilizes the film, and it has a spreading property, so foaming won't be there. So that's antifoam agents. So many compounds can be used as an antifoam agents, but we are incorporating this chemical into the medium, so we need to consider so many things before we incorporating a extra chemical into the medium. So these are the ideal characters for an antifoam agents. I'm just telling all of them. These are the ideal characters. We may not be able to find something with all the ideal characters. So first point is readily dispensed with a rapid action. Dispersed with a rapid action. So the action should be rapid. Whenever the foam is generated, we will pump the antifoam agent into the media. So it will disperse fastly, and the action should be rapid. The foam should disappear quickly. High activity at low concentration. So as it is a chemical, we don't want to put it in high amounts or high concentrations. We want it put in very small concentrations so that the negative effects won't be there. Next one is prolonged action. Once we add the antifoam agents, it should act for a very long time. Otherwise, the microorganism should not do anything to the antifoam agents. It should be there and it should have activity. It should be non-toxic to the microorganisms, humans or animals. If the antifoam agent is toxic to the microorganism, it will kill our microorganism. We don't want that. And the humans and animals, it should not be toxic. If it is toxic to humans, it will be difficult to handle in the industry. If it is toxic to animals or the plants or environment, it may lead to the pollution of the environment, and it will complicate the wastewater treatment process. Low cost, we always want things in low cost. Thermostability, it should be stable in high temperature because some of the fermentations are happening in 55-60 degrees Celsius. So the antifoam agents should be thermostable. It should be compatible with the media components and the process. So it should not react with the media components, or it should interfere the process. So it do not affect gas and mass transfer. Sometimes if you add some good antifoam agents, what it prevent the formation of the film, but it also prevent the gas exchange. The smooth passage of air through the medium will be affected, or the oxygen dissolved oxygen level may be affected, though that should not be that's not ideal for an antifoam agents. It should not affect gas transfer and mass transfer, and it should not affect the downstream processing, the purification of the product. If the antifoam agent should be easy to remove, so otherwise it will interfere with the downstream processing and the purification of the product. So these are the ideal characters, and we have natural and synthetic antifoam agents available. We always prefer for the natural antifoam agents, which include plant oils like from soya oil, or the sunflower oil, rapeseed oil, which can be used as a antifoam agents. Or we can use fish oil as a antifoam, chemical antifoam. But the thing is that it should be deodorized before use. Otherwise, your product may look like may smell like a fish. That's not good. So deodorized fish oil can be used as a antifoam. Then mineral oils can be used as a antifoam. But these oils should be purified. It should be super pure before we using it as a antifoam. Otherwise, it may interfere with the process. Synthetic antifoam agents including silicon oils, polyalcohols, or alkylating glycols. These things can be used as a synthetic antifoam agents. So that's all for this session. Thank you so much.